Okay, so we're going to go ahead and get into chapter 4, repetition structures. It's another control structure, and it works kind of like the if statement in the fact that it's always looking for a true to continue repetition. So essentially, repetition is what makes a computer smart. And speed is what allows for speed and repetition allows for artificial intelligence and automation. So a lot of what you'll do happens to be dealing with repetition, and the first type of repetition is one that is explicit, which means that you're going to be using a while loop and a for loop in your code. There's another kind of repetition that's kind of like your game draw event that is called automatically every like 5 milliseconds or something. Those are event driven repetition structures. So what you're going to be doing until you learn how to work with those, which will not be, it'll probably be out in the workforce most likely, unless you want to start building a game. But let's go ahead and get into your initial entrance into knowing a little bit more about loops and how they work. So we got a while loop and a for loop that we're going to be talking about today. So let's go ahead and start with the while loop. Now I'm going to do mostly demo today, just kind of give you guys an idea of how to work with these things. And then kind of loosely use the PowerPoint. I believe that what we were doing last week just popped up. So I'm going to go ahead and use Visual Studio Code here. And we're going to start writing some code for chapter 4 or module 4. Okay, now a while statement is kind of just like your if statement, and the fact that it, well, sometimes this stupid silly thing just drives me nuts, this Visual Studio Code. It looks for that true statement. So, and it uses relational operators. So it's a control structure. So it uses the true false like an if statement. So it behaves like an if statement and how it's evaluated. When we talk about like control structures, we can do something while something where we have a while loop and we can say while x is greater than or less than 5. And so right here it uses a relational operator to determine whether or not the while loop should continue repeating. And what you do is you tab in the instructions you want to happen inside the while loop. So remember, the tabs are important. So it actually puts the code that you write when you tab in underneath the while loop. The code that you write is going to be the code that that is going to be repeated. So what I'm going to do here is I'm just going to do a simple x is equal to x plus 1. And then I'm going to print x just so we can look at it. Now, if I were to do that, that means that that print statement would only run one time because it's not part of the while loop. This now puts it in the while loop, and that's what we call scope. So the scope of the while loop is with the indented code, and those will be the statements that are repeated. So let's look at the behavior now. And what I've done is I've said as long as x is less than 5, continue to repeat, because all the while loop cares about is a 1 or a 0. That's all it cares about. So a while loop will, well, okay, Python, true, false, but it's still a stupid 1 and 0. So anyways, that's all the while loop cares about. And whatever expression you have in here, it has to, needs to be a relational expression that evaluates as a true or false. So, even if you start getting a little wild with things, take it and add 3, divide by 4 type stuff, that code will run. But remember, it's just like the if statements. It only cares about that true or false after everything else is done in order. So everything that we did last week is directly applicable to what we're learning now with the while statement. So we're not going to spend too much time on that. So let's go ahead and set the debugger and just look at the behavior. Okay. Well, I guess start debugging. Fine. Okay. Sure. Go ahead and do your thing. Let's open that up so we can actually have something. Okay, so we set the x is equal to 5, and then we say, hey, while x is greater than 5, and some of these guys need to go away. Oh wow, look at that. Okay, I guess it doesn't want me to get rid of those. Okay, so we can add our x is greater than 5 expression here, and we know it comes out as false. So x is not greater than 5, so it's not going to run at all. So we're going to say while x is less than 5. Now that's different. Oh, no, because x is 5. Let's say x is 0. So now this is different because x is now less than 5. So therefore, the while statement is going to come out as true, and it's going to complete the statements inside. Okay, why are you doing that? Okay, well, yeah, there we go. Okay, so x is less than 5. We got false down here. Now what we do is we do an x is equal to x plus 1. Now x goes up to 1, and then we print x. And you can see down here in our terminal, should show up. It might show up afterwards, but you should have, let's go to output and just make sure that we are, so printing x, you know what, we probably got to convert that to a string. That's why it's probably not liking us right now, which is fine. But actually print should be able to handle that. So, okay, so it just did it after it got done doing all the steps. So we have our output, which is going to be, it looks like 0. Well, let's run this again. Run without debugging this time. We got 1, 2, 3, 4, 5. So we start x at 0, and we immediately add 1 to it. Now you notice here that I'm starting at 0, and I'm going to less than the amount of numbers I want to do, because you can do less than or equal to 5, and then the loop will run 6 times. But the best way to do things is if you're running a counter for a loop, always start it at 0 and go to less than the amount of times you want it to run. So that means it only goes through 0, 1, 2, 3, 4. And you can look at that by changing where we print. X is equal to x plus 1. Okay. Now we're going to have a little bit different behavior. We're going to have 0 to 4. And that's because x starts at 0, and the first statement we do is we print x. And so it outputs 0. Then we add 1 to x, and the repetition happens again. So let's go ahead and look at behaviors all together. X is less than 5, print x. There it is down below. Add 1 to x. Is x still less than 5? Yes, x is now 1. Print x. Increase x by 1. Now, is x still less than 5? Yep, x is 2. Go again, print x. Add another 1 to x. And then it continues all the way up until where you get x is equal to 5. Now this is where we call a fence post error, because there's always going to be like an off by 1 issue here, and I kind of showed you that when I changed the print statement and flopped it back and forth. So when you're looping to reduce the off by 1 error, you always want to start at 0. And here's the thing that you want to get in your head. In programming and in the real world, 0 is not 0. 0 is actually the number 1. So, and 1 is 2. So 0 is actually something, so we count it as something, even though it's 0. And in higher mathematics, the 0 is implied. But when you're taking it into the real world, the higher mathematics into the real world, you actually got to deal with the 0. So it's kind of interesting to work with off by one errors, but it's something you get the feel for after a while with more experience. But this is what we call a simple accumulator, and it's going to be the counter that we use to determine how many times that we iterate. Now, one thing that will cause a problem is we have what would be called a runaway loop here now, since what I've done is I'm not adding 1 to x anymore. So x will never be 0, therefore that print is just going to be going on forever. And it is going on forever. It's continuing to print 0 right down here because it's just continuing to repeat. Oh, is x less than 5? Yep, it is. Print x, which is 0. Is x less than 5? Yep, it is. Print x. Is x less than 5? Yes, it is. Print x. Because we're not putting x to 1, so there's no way to break out of that logic. And we have what's called a runaway loop now. And you can see it. It's just down there printing. It's just ridiculous how crazy. I mean, look at all these zeros we got in the window. So I'm going to force quit it. And, I think you can do a CLS here to clear. Yeah, you can do a CLS to clear your terminal. That's some terminal stuff. I believe that's, I don't think it's clear, but CLS does it. Yeah, CLS will clear your terminal. So, the while loop is what we call a pre-test condition, meaning that it tests first and then it does the repetition. Okay, so repetition and count control loops, we just covered that. Now with the while loop, contains your different parts of the while loop. It has 3 different parts. You have the while statement itself, the condition that you're working with, that's your true or false, and then the statements that you need to be done repetitively. Okay, so let's look at the for loop. The for loop, we just talked about infinite loops. The for loop is something that's more controlled. And this is the one that I say you should always use. While loops are they're not really, they have too many problems. They're more difficult to deal with off by one errors, and the for loop is just more controlled. You have more control over it, as you build it, so that the propensity for a runaway loop is a lot less. And so I recommend to just, if while loops make sense for some things, but if it doesn't make sense, then a for loop. Always use a for loop if you can solve the problem with a for loop. And the for loop is controlled, and you tell it where to start and where to end all in the one line. So you say for a variable in some kind of range, then you output those statements. So let's go ahead and just kind of look at how that works. So what we're going to do now is the x and the condition, they're all built into the for loop. So your while loop is part of the 3 parts, but the for loop contains all of it. So I'm going to say for x in range. Now this is interesting. We're going to put in range of 5. Now you're wondering, okay, well, where does x start at? Well, x we don't have to declare because being declared here, it's going to automatically be assigned 0. And the range, when we say range of 5, we're saying go from 0 to 4, I believe. So let's just look at how it behaves. Okay, So we got in range of 5. So where does X start out at? Let's look at the behaviors, and we can look at our locals. X is not going to be created until after we do a step over and run this first line. Now X is created, and it's automatically assigned the value 0, because when you use this in range, it starts the first value at 0, and then it's going to go and run 5 times. That means it's going to start at 0 and end at 4. Now this is appropriate because you're like, oh, why doesn't it start at 1 and end at 5? And I'm like, no. Learn, 0 is 1. Because of off by 1 errors, that's the reason why you have to treat 0 as 1. But you see here that we get the last bit, and then it stops, and we have the numbers 0 through 4. And that's just basically doing exactly what I did with that while loop. But it's controlled automatically for you, and you just have to say what range you want. Now you can say I want range 1 to 5. Now this run will only run 4 times, and it'll start at 1 and end where? Because I believe this is an inclusive and this is exclusive, meaning this is off by 1, -1. And this means we start at 1 and we go to 1 less than what the value is here. And that's what it means by exclusive. So that means that we're going from 1 to 4. I could be lying though. I've lied before, but let's see what behavior has. Okay, so X starts at 1, goes to 2, goes to 3, gets to 4. Yep, 1, 2, 3, 4, just as I thought. So the first argument in that range is what we call an inclusive. That means it's an argument that we pass to the range function that says, hey, this number is inclusive, and that's the way the function is built. And you can see when you look at range which argument is inclusive and which argument is exclusive. And we know that the first argument is inclusive because we start at 1. But the second argument we know is what we call exclusive, meaning that is off by -1. It's the fence post issue is built into the very language and the way you do things, guys. It's just the way it is. So this loop will only run the 4 times, going from 1 to 4, because that second argument is exclusive. Now, if I change that to 5 or to 6, excuse me. Now it would run 5 times, but it would run from 1 to 5. So inclusive 1, it'll stop at 5, 1 less than the exclusive argument. So we'll run this one without debugging. There's our 1, 2, 3, 4, 5. So the for loop is a much more controlled loop, and there's actually more forms of that, because you can say for x in. And this right here, instead of range, you can say an array or a list of items. So it kind of acts like a for each statement in some of the other languages in a certain respect. It can do both. It can do both. So mostly what you'll be doing is using these for loops, and or what I suggest that you use other than while loops. Okay. All right, so this goes through a little bit on the iterations that I showed through the debugging, and we talked about the range. And using the target variable inside the loop. Okay, so we did that. That's actually X here. That's the target variable. That's the one that's actually making a change. That's what we also call an accumulator. And you can also ask the user how many times they would like to repeat a loop. So what we could do here is we could say, hey, user, how many times? Oh, wait. I'm writing in two. I'm trying to do this in. Okay, so because we could just do it with the input. Okay, so I'll say X. Oh, wait, no. Let's do this. Let's do this limit. L is equal to convert what we get to an integer. And then what we're going to do is we're going to ask for input. And the input we're going to ask for is how many times. I think I might have a syntax error here, but we'll find out. Okay, let's start the breakpoint there. But instead of having 6 here, we're going to do L. But remember, it's inclusive. So we got to add 1 for the fence post error because we're asking the user how many times you want to run the loop, not how many times does it end. Let's see if that actually even makes sense. Let's start at 0 like we should. How many times do we want to run the loop? You know what? Actually, yeah, we don't do a +1. We just do an L. Let's see if it works appropriate as I figure it would. Okay, so start debugging. Okay, let's go for our input. Now, when I do a step over here, I can't put my input in yet, but when I do a step over here, it's going to then ask me for the input over here in the terminal area. So I did a step over, it's run this line of code. Now I got to go down here and you see it says how many times down here. Now I got to put in the input for that. So I'm going to say I want it to run 5 times. Okay, so now L becomes 5. And I don't want to do step over here, so I'm just going to hit play so it continues and it ends up. So yes, it went from 0 to 4, so we don't have to do that L+1 thing. But so you can the user can choose how many, the repetition, they're all variables. You can use them and they can vary. You can change those values. Okay, so here is a different way of doing things, which is when you do the range, you say start at 10, end at 0, but every time in the iteration, subtract by 1. Because in our example, it's implied that we want to stop at L and iterate each time by 1. So if you omit this argument, it automatically iterates x by 1 every time. So what it does is this argument, it would be just like I showed you in that loop, x is equal to x plus 2, would be what's happening behind the scene, or 1, excuse me. But if I change that to 2, then it would be x is equal to x plus 2. So all it's doing is it's telling you telling the for loop how many times to iterate x between repetitions. So that means that we are going to stop, and I'm going to go ahead and hard code this so that we don't have to mess around with this stuff. So this is a line of code that says go from start at 0, go to 6 or 5 actually, but every time you iterate, you add 2 to x. And then I'm going to give you a question. Well, how many times does this loop run? Well, if it goes from 0 to 5, but every time it adds 2, that means it goes from 0 and it runs, then it goes to 2 and it runs, and so it's run twice now. Then it goes to 4 and it runs, and now it's run 3 times. Then x goes up to 6 and it's done running. So does it run 3 times or does it run 4 times? Well, that's why we got the best cheat sheet in the world. It's called your debugger and your compiler or your interpreter. And you see here that 0 to 4, it only ran 3 times. And you can actually, I got to set my breakpoint on an actual line. There we go. Okay, so here's our first one. X comes out as 0. Then x is added. We add 2 to x. And we print it. Then we come back. We print x again. And it's now 4. But now when we've added 2 to it, it now fails the exclusive argument of the value 5, or being up, it is now equal to 6. So it stops running. And you continue on. So that one only runs 3 times. And this is a very common issue with loops in that off by 1 error, is how many times does the loop actually run when you got weird, crazy stuff in here, like, oh, let's start at 10, go to 0, and subtract 1 every time through. Now, what does that do? Start debugging. That's where you want to do your own examinations and start debugging on your own, guys. This is something that you need to do, especially if you want to be extremely successful in 202 and have lots of dates, or actually, social life, or spend time with your kids and your family. Okay, so we start at 10. We tell the range to start at 10. We are going to stop at 0, which means that's exclusive, which means we're going to actually stop at 1. And we're going to subtract -1 each time. So we X starts at 10, we print 10, we subtract 1 from it. Now we got 9, 8, 7, 6, 5, 4, 3, 2. Now since the 0 is exclusive, is it going to actually print? I don't know. Let's find out. No, it doesn't, because it's exclusive, and that makes sense. Okay, so this is now run 10 times, and you notice we're starting at 0 and going until less than 10, or starting at 10 and going to less than 0. So that off by 1, it's all over the place, guys. It's part of one of the things that makes this kind of difficult and kind of visualizing. But again, the debugger helps you do that, and you can see it actually work in action. Okay, calculating a running total. This is something that we call an accumulator, and often what you'll have is you may have a total, or how about this? It's an assignment I used to do with some of my younger aged students. It's the grains of rice problem. If you were given 2 grains of rice to start with, and you were told that tomorrow you would get double the grains of rice as your previous day. So you get 2 grains of rice the first day. The second day, you get 4 grains of rice. And the third day, you get 8 grains of rice. So what's the total grains of rice? Well, the total grains of rice you have after 30 days, you've got to count up this total, 2 plus 4 plus 8, but you also got to keep a running total of what your current value is for grains. So what we'll do is we'll start with grains as a variable and start it at equals to 2. And then what we'll do is we'll say, hey, we're going to do something. We're going to say for 30 days, how many grains of rice would this individual have after 30 days? Now I can put 1 in there, or I'm just going to omit it, and this is the same thing. It's going to automatically add 1 to it. So how many grains would I have? Now we're now just using X as a counter for how many days we're going to be collecting grains. So after day 1, I say grains is equal to grains times 2. And then I need another variable to hold your total for each day, because if you start with your total of 0, then I'm going to go ahead and do the same thing, but I'm going to use I'm going to do the same thing as this, but I'm going to use the trick for this one. Total plus equals grains. So this is a running total of how many grains I got for that day, but each day that comes in, I double how many grains I get. So this is it's a little bit on the complex side. So let's look at actually what happens in the loop. Okay, so now I go in there, print grains, we get our 2. We double the grains, and then we total the grains. Oh, we made a mistake already. The total should be before, because if we do it times 2, we need to say total plus equals grains first, because we need to add the 2 first before we double it. So then I'm going to go ahead and print total, just so we can kind of look at it. And then let's put our print grains down here. Actually, you know what? Let's do our print total and grains up top, because that's actually where it starts. And then we go to the next day after the loop is run. So this is actually the start of our day on our grains. Total. Okay, print total. Okay. So our first day, our grains are 2 and our total is 0. So let's go ahead and run this, start debugging. Okay, I step over, our grains is 2, our total is 0. Then I say total, we add total, so total is equal to total plus grains. Then I do a grains is equal to grains times 2. Now the loop comes over again, but grains is now 4 and total is 2. And then it adds up. Well, what's the total now of grains? Well, since grains is 4, and our total started 0, our total is 2 from our previous day. We're on a new day now. And now our grains are 4, so we're going to add 4 to total here. So now after day 2, we have 6 grains. Then day 3 goes, and each time it doubles. And you see how it just gets crazy after a while. So I'm just going to hit play, and we're going to see kind of what happens here. Oh, let me remove the breakpoint and finish it up. Okay. Okay, so after 30 days, you have, what is this number? 1 gazillion or something? Grains of rice? But, you know, this is an example of accumulators. And this is actually a problem that you would want to go in and try to solve with a formula. It can't be solved with a formula. You can't solve this problem with a power function. It has to be done with repetition and accumulation. So that's kind of where I want to, get you towards for today. Let's go ahead and look at our PowerPoint and kind of what we haven't really kind of go. Okay, I already showed you the shortcut. I just used it. Sometimes you may want a running sentinel, and sentinels can be used to describe an end of input. So let's say that we asked the user for input and we wanted the user to continue to input numbers until they entered a certain value. And then the loop would terminate. So that goes into input validation. And one thing that you can use a while loop with is for input or validating input. And that's where a while loop actually makes sense instead of a for loop. So, and just like if statements, you have nested loops that are possible. But what I wanted to do is before we, I kind of got you in a little bit on, where I wanted to go with. The last thing I want to do is show you the while loop for input validation. Or actually, you know what? Let's not do it for input validation. Let's do it for a sentinel. So what I can do is I can say, hey, let's get input from the user. And we can say, hey, this is going to be input from the user. And what I'm going to do is I'm going to write a while statement here. And I'm going to say while. And this is kind of funky, but you can actually take your integer input and I so hate Visual Studio Code sometimes when it does that stupid insert automatically. Okay, so while enter a number or -1 to quit. So what we'll say is while the input that we're getting, actually, we don't want it here because we want to assign that to a variable. Let's not be cute. Okay. What we're going to do is we're going to just put in I'm just going to put an I equals 0, and we're going to use I for our input. And we're going to say while I does not equal -1. And then we're going to get the number. And we're going to say I equals integer of input, enter a number, -1 to quit. And then we're just going to print I. Okay, so well, let's examine this behavior. Okay, while I is not equal to -1, we start I at 0. We ask for a number. I put in 3. Okay, then we print 3. We go back in, we ask for a number. I put in 2. I put in a number. Oh crap, that didn't work. Okay, so essentially, I'm going to do this without debugging. And what this does is it just continues to run. And you can continue to put a number in. Here I am just putting my numbers in and printing them over and over and over again. You know, and then it's not until I hit -1 that I'm saying quit, and then the program comes out. That's an idea of a Sentinel. Okay. I think I got the main concepts of loops out to you. With input validation, you can use that for input validation because you can say what they input, and if you're looking, let's say that you are looking for the value -1 to be input, or another value that you want to check to make sure that they input correctly, and if it's not correctly, then you run the loop again and ask for the input again. Okay, I think that hits pretty much what I wanted to cover. One thing to look into. No, actually, I think we hit it all. Alrighty, guys. Thank you.